Okay, then history of artificial intelligence, as I was telling, it is not
When
a
it
one
was
day or
live
2 day
stream.
job. Yes,
Uh,
I have started a live stream.
okay, okay, ma'am. Thank you.
Okay. History of artificial intelligence is not a day or two task. It has been building along ages till now. Like in this graph, as we see, 1943, the evolution of artificial neurons or artificial networks started to begin. Uh, the uh, the term Turing machine came into being, in which we could see that a man was behind a computer system, and on the other end, it was just a system that could work as a human or depict a human uh, on the where the same as a human was interacting with another human on the other end. It was interacting in the same way. Like birth of artificial intelligence was known in a Dartmouth conference. First chatbot was also um, there in 1966 as Eliza, and of course these all this evolution was going on in a developed country and mainly in USA. And there were expert systems developed in 1980, the first expert system maybe. And then there was with the World War II, there was continued evolution in artificial intelligence, and IBM made its Deep Blue computer. That was first computer for artificial intelligence. Then IBM's Watson came into being. Google right now and as Siri or a co-pilot of Microsoft or Amazon is building artificial intelligence. Is fast evolving artificial intelligence right now. Okay. These are the applications where we have tested our artificial intelligence systems or analytics, like space, like we know about drones and spacecrafts that have been doing scheduling tasks, like they are being uh, promptly or focusedly told to do a task, and they do it exactly at that time and in the exact direction that is being uh, uh, told them to, wherever they have to drop any shell or any food item or anything in any place or location, right? So we can learn about geographical areas as well through satellites and visionary systems as well. Beating Gary Kasparov in a chess match, of course we know that in the games as well, artificial intelligence systems are um, beating humans in that. Steering a driverless car is an example of a robot. Understanding language, like we can translate using Google or any chatbot from Urdu to English, English to Urdu, or any other language like Spanish, Italian, you name it. There are several languages, for example, around 50 to 60 languages that we can translate around. Robotic assistance in surgery as well, like in healthcare, where MRIs, brain MRIs are being scanned, or heart surgeries are being designed. We use robotic assistance. Okay. In diagnostics as well, we can predict we can predict diagnose we can help doctors in diagnosis as well, or prognosis of a disease as well before time. Okay. Monitoring trade in the stock market to see if insider trading is going on, like I have told you. Like we can know through regression line or regression analysis that if a business would be profitable or would be going in a loss in future or something like that, depending on the research and studies on the data that is being that we have. These are some applications where we see artificial intelligence working these days, like social media, where the all the humans or public is on social media right now. These are all the known applications. Our data is being studied, analyzed. Our faces are being analyzed, tagged, and any person that is on social media through can be can be analyzed through emotions and pictorial images, how he looks or how he behaves in a certain way or something like that. In education, agriculture, transport, healthcare, anatomy, like space technologies, we know of SDGs 18 that is being built on. We all here also artificial intelligence systems are working, satellites are being built, and for geographical analysis as well, for climate and environmental prediction as well. Finance, gaming, data security, we know when we talk about cyber security or cloud security, where we build or integrate these analytical systems, we need to embed data security as well. And for data security, even artificial intelligence systems are being built, or algorithms work on data, like to analyze where the data breach is being uh, generated, or any intrusion is being uh, detected. Okay, automotive, like self-driving cars, robotics, entertainment as well, like media is using artificial intelligence every day, e-commerce for businesses, business analysis, and so on. Okay, I guess this is time when we can shift our this is and artificial intelligence actually is a problem solver for our based on the data. It can be rule based on inference engine, where we can draw conclusions or our best results. Okay, this is the diagram, how artificial intelligence is being built for machine learning and then deep learning. I will go through this. Like machine learning is, of course, when an ordinary system, that is automated system, any computer system or a calculator is changed into artificial intelligence system uh, to predict or automate, to do automated decisions given some data. And its advanced form is machine learning, that analyzes some large amount of data and for prediction or learning something. This is how we input data into a system, analyze data, find patterns to predict or decide on something, like diagnosis, or in education, like results building or student score as well. And even the system learns from the feedback, that is known as reinforcement learning, if anyone knows here about that. Okay. Let me see. Okay. I wanted to see that we have some time. Types of machine learning, supervised learning. I would be discussing today with the data that is being given to us, right, for analysis. Supervised learning is the basic artificial intelligence scheme or technique, where the data is given to us is labeled, out of which we separate some training data and test data, on which we uh, train our system or analysis. Okay, algorithm. In unsupervised learning, we have some unlabeled training data, on which we train our system to predict or to tag the data based on some group of data, and reinforcement learning, that is the system which learns from the current scenario. Like if a self-driving car is driving, it would learn on the road, where there is a change in direction, or where the road is turning, or where there is a block or something like that, or traffic signals even. It would be learning with time and with uh, revisions, like. Okay, I hope everyone is with me.
Yes, ma'am, you are doing a great job. Kindly continue.
Okay. Uh, then, as I have told you that machine learning types basically are three. There are more as well, but basically there are three types. That is supervised learning, unsupervised learning, reinforcement learning, and within this supervised learning and unsupervised learning, there is another type, that is semi-supervised learning, in which some data is labeled and half or the other data is unlabeled, right? Of course, during the training we would be studying how the data can is supervised, unsupervised, semi-supervised, or reinforced, okay, or based on reward system. In supervised learning, we basically with the labeled data we can do classification, regression, clustering even, or based on rules we can do association, rule mining. Okay. And in unsupervised learning as well, we group the similar data and tag that data, like if it is a food, if it is a sports as item, or if it is some clothing or something like that, uh, based on pictures or like or something, or even that its texture or of data, or like the group of data that is being collected together, any kind of at any kind of pattern that we can draw, it can we can cluster it together and tag it with the associated name. For example, supervised learning, where we have a labeled data for sales forecast, like we have some items for which we have uh, their past prices or the cost incurred. Then there is some with the time the cost or prices changed, and the current scenario in which today's cost is incurred or prices are given. We can or some condition or some external conditions like weather change or something like that, or the demand that is being uh, decreased or being increased, say is like the supply item, the supply of items, if it is being increased or decreased. All these factors can predict the sales forecast, if it would if the sales would increase or decrease with time in future, right? uh, the same is the case with stock price analysis. In the if we can predict how the business is going from the last decade or two, and within a year how it changed, how the scenario of a business changed, and how it would grow in the future as well. Same is the case of with weather or environmental prediction, like floods, or in any case how the crop would grow or something like that. In unsupervised learning, we can segment our customers based on geographic location, or based on age, like, or the demographics, right? And there can be other algorithms for unsupervised learning. For reinforcement learning, we have some games, like the person is playing, and the game is learning through the moves that he is making, and in the another uh, run it would become better and better and better with the reward system. Like if the first move was, if it was right, it would go on, or if it would be wrong, then it would take the person to another or change its direction of game, something like that. Then this is the way how that robots learn or get trained, like in self-driving car as well. Okay. uh, the values, we should know how the data values are being the categorized. Like there is a data that is solely numerical, like age, salary, height, or something like that. Or other data that is like in text or something, it can be categorical, right? Like color is red or blue or something like that. dogs beat, like the text or gender is female or male, something like that. So it categorizes based on text. In supervised learning, as I told, when the data is labeled or we have some two variables only, some small set of data where there is weight, height, and we have to predict based on that, we can do regression algorithm and estimate the relations between variable to predict some any kind of target variable. This is how it would look, a regression line. For example, we have some training data. We would train our algorithm, regression algorithm, over that data, and it would draw some line given on that data. ठीक? Then we will enter a test data or some new data that is unlabeled. Okay, that is not we know this the regression algorithm that is being trained on training data, that data was labeled. Okay, for example, this is apple or this is orange. Yes, and in the regression algorithm we have some two category two two items or two baseline target variables, like yes or no, 0 or 1, in which we will get a resultant of our prediction. Okay, so it will be either yes or either no. So when we would be when we would test this algorithm on our unlabeled data, it would categorize or label it on this given regression line. Either it would fall here or here, and the distance of it would tell us how much error rate is can be there in. For example, if it is data lies here, it is near to this line, and there is chance of uh, truth in it, like 98 or 97% accurate result, for example, we can determine like this. This is our regression line, for example, from the training data here. But if we draw the line here, then all these data items would be above the line, or the distance would as well would grow, and we would know that there is some error in this. We have to make this regression line between where the distance of all these training data is minimum. That would be the accurate line. This is how R&D is being done for marketing, administration, and state level geographic data as well. And we can do predictions. This is example of a business profit and loss based on R&D expenditure and something like that, right? Now we can do some our lab on project Jupyter Home. Um, we would do an example of linear regression and do some data pre-processing as well. Let's see. Um, okay, this is only a link where we can install our Jupyter notebook, where we run our Python code. Okay, I have this Jupyter notebook on this system, so I would open from here. Let's see. After it, we will go through some GitHub installation and all this. It would, I guess we have a half an hour or so. We can carry on. Yes, exactly half an hour we have to do this lab. Okay, in the audience, who has some info on artificial intelligence and what I am doing or saying or discussing with you till now? Are you all with me? Hello?
You're doing a great job.
Okay, will do keep let me posted of everyone's attentiveness. Yes, I would like to be sure if everyone is going with me, is with me. Okay, in this Jupyter lab, I have some projects that I have built with time. Let's do an exercise within this project. Let's play with ML. Okay, I'm opening an already made file that is in Python. Okay, this is linear regression based example that I would be running. And here we have some data sets in this folder. I will let you know how the data is from where I got this data, and even the code is repositories we have in GitHub. Okay, I will let you know how to download and how to use GitHub for sharing of data, or to do teamwork even on these files. Let's see. We have this code now. Um, Actually, this artificial intelligence training that I would be doing is for everyone. I have launched this training in the hope that I can relate with anyone who is interested in to know artificial intelligence and how it works in the back end. Okay, this code, for example, if you have any kind of basic training in coding, or practice in codes, for example, even in C, C sharp, Java, or C++, if you have a concept of object oriented languages, you would be understanding how the Python works. Okay, even if you haven't worked in Python before. All right. This is in the C language as well. We import some libraries or something like, okay, uh, or uh, it, import some functions. All right, so this is pandas, the library that we import, and name it as pt in a short form. Okay, numpy is for numbers library. Okay, and we name it as we small it with np. And this matplotlib is for to plot figures. Okay, and the data set is a variable here. We use pandas library to read csv file that is studentscore.csv within this datasets folder that we have here. For example, I showed it to you. Yes, this is the data sets, and this is student scores that we are playing, that we would be playing with in this here. This the block, it is in blocks and very easy to run this code. I would be using short keys, that is shift plus enter, and it would be the code is running. Okay, this star sign shows the code is in running stage, right? Or we can run it, run the cell from here as well. Okay, so we can wait until this code completes, the run completes. See, this star is changed with the number, and now we will run this block. Actually, this student scores file is read through pandas library, and it is stored in this variable dataset. Now we would run this dataset. Sorry, shift enter, and this data shows that we have some two columns, that is hours and scores, with multiple rows, for example, like this. Okay, it shows that for example, 2.5 hours of work, a student gets him the score of 21. where the R's increased, the score of student increased as well. See, this is how we see our regression line, like y is equals to mx plus c. If everyone knows of this this function, we have practiced it a lot in our mathematics problems. Okay, now I will run this other block that would uh, shift all the values from in rows and columns into the x within the x variable as an array. See, this is I location. I log is represents location. Like this is the rows. These are the rows from 0 till end, and this is the column from 0 and 1. Okay, this is how it works. So the x variable contains all the values in array form. Now we will take y as a target variable. Here actually I will tell you that actually this x variable contains only these values, the number of hours that a student has studied or worked on. Okay, this column only, the column number 1. Actually, this is the column number 1. For example, uh, this this is represents column. So the colon and this number 1 represents that till the column 1, like read columns till 1. So it would only read the first column, that is 0 column. Okay, and here when we don't use colon, see, here there is no colon. It is not 0 to 1. It is only 1. Like it is only the 0 column was first column, and the 1 column is our second column, that is student score. So we can read y variable through I location, and this is how the array is built. These are all the student scores that are shifted into y variable. Now we will split our train test data. That is like we have an x data and y data, and we will make it into 80-20 rule. Like 1/4 represents that 25% of data would be test data, in which we would have only unlabeled data, that is uh, x x data, and the target labels won't be given in the test data. The other 75% of data would be training data, in which there would be x training data and y training data. Okay, so here this uh, would split our data, and using in another this is another library, sklearn framework, from which we import our linear regression model. Okay, so, and this linear regression model is we make a variable out of it, and we train this model on x train data and y train data. The other now we have introduced a y prediction variable, right? And using this model that we have made a variable for regressor, we predict based on x underscore test data. That was only 25% of data. And now when we have predicted our y prediction, we can actually, let me show you here. This cell we have run we can add another cell after it using plus sign, and we can use y underscore predict, the same variable in which we have predicted some values. We can see which what kind of values we have got in y prediction. See, these are the scores that we have drawn for our test data that was in x underscore test. We can see. We can also see our x underscore test variable as well if we want to see. Let me show. X underscore test. So we would know that on this data we have some predictions like these. For example, 1.5 hours of work from student got around 17 number of score, and so on, because this is a regressor line. We have a model, regressor model, linear regressor model, and this plot code is to draw this diagram. Okay, like plot dot scatter. Actually, we have created this variable when we used the library that was this import matplotlib.pyplot. We imported this library for figure and short form and formed the alias of it as plt to plot. Okay, so let's see. X train, Y train, we have color is equals to red. This is our training data. Okay, and our this we will and prediction line we will draw here in blue. This is regressor dot predict, is the color would be blue. This is we got. All right, and now we see. Okay, right, again the in another scatter plot, the same it is the same kind of code, but we have taken x underscore test, y underscore test to plot, and we will get the another graph that would be demonstrating us the only the test data. This is how we have predicted our y target value. Hope it is understood. This is a small example of learning through data. This was a small data actually. So and small there were small data points around I guess 10 or so. Yes, there were 25 data plots that we have done our work on. I hope it is understood. We can do another small example, but I won't. Oh, sorry. I have closed it. Okay, there is another data pre-processing step as well. If you want me to go through, but actually we can do it in during the training as well. Let me know, because I wanted to go on through installing of GitHub. Let me know if you want to learn how to install GitHub, or you want me to go through the code. Hello?
Yes, ma'am.
Uh-huh. Shall I continue with GitHub?
Well, it's up to you, ma'am.
Okay, let me go through the code as well. I guess we have some time after 10 as well. If you are not busy, we can do GitHub again. Okay, I will
So it seems,
totally,
ma'am,
actually,
I
I
just wanted to
will,
add something.
this is data pre-processing. Uh, this is how again we import some libraries, NP and pandas, NumPy and pandas. These are primary libraries that you would install in any scenario. Okay, this is how. Now this data is data.cv in the datasets folder, and it has some multiple columns, as you see. Okay, uh, here we have used two, so it is only showing us number of 2 rows. If we delete it, it would be showing us all the rows that are 10 records. Okay, and the labels are only 2. That is, this is the purchased target column, that we will make it y column. Okay, and like no or yes, this is we can say this is binary values, no or yes, 1 or 0. And based on these 3 uh, columns, we would be predicting our purchased column. Okay, this is a scenario, but I will only discuss it till data pre-processing stage. In x, in the variable x, I will take, like -1 shows us that from 0th column, like this country column, till the second last column. Okay, it is 0, 1, 2, and the last column is the column 3, that we will be saving in y variable, that is a target variable. Okay, so we have to store only first 3 columns in our x category, x variable, and we have used to represent these columns as colon -1, that represents second last column of the data set. So we run it. Okay, and we run it this as well. We got both the variables x and y. Now we read x. X has first 3 columns, that is country, and the other columns are age, I guess, and salary. Okay, and in y column we have these binary values, no or yes. For example, if this is the country demographics and this is the age and this salary, either he can buy or he can buy or not. Okay, the purchasing power is yes or no. sk learn, again we run it, and actually the nan values, if you see that these readings have some nan values. Okay, for example, in the salary column we have this nan, it shows that is like empty column, empty cell. Okay, and here in age it is an empty cell, it is null value. Okay, so we would impute it, like it replace it. Okay, replace it with the mean value, as it is a number, we can replace it with the mean value. So let's I guess we have run it. Yes, so wherever it was null, it got replaced with a mean. Now we read our x reading, and there is no null value. If you see, this was the null value here, it is being replaced by this salary, and this was the null here, it is being replaced with this age. And now if you see, this is the first column, it was country, like categorical data that I told you. We need to replace it with number to make it easy to analyze. Okay, this is data pre-processing. Like we need these countries to become numbers. So through label encoder and one hot encoder, first using label encoder, we will transform our X column, that is um, 0 column, first column, for example, that is country, into these numbers. Okay, so run it, and the countries have changed into 0, 1, and 2. We have 3 countries, France, Germany, and Spain. Okay, so it is changed into number. Another form of label encoding is like this, when we want to transform it into using one hot encoder. Okay, like the first column, that is country, would become in floating value, and the other all columns would remain would get joined with it without any change of value, but it would represent like this, this array, it would be changed into. This is actually the coding related thing, how we would like to code. We can code, we can analyze data based on this data as well in the number form, or we can, if needed, we can use this one hot encoding as well, array. Okay. This is only the data pre-processing stage. We won't be using any algorithm on it at the moment, and this is the why we encoded it as well. That was yes or no into 0 and 1. It has changed into 0 and 1. Here above we did it here in this. Okay. Test and train data were split, and again we would this is the standard scalar that we would use for to transform our X train and X test data. This is a scaling value like this. This is X test data, you can say. So if you see that it has scaled into like this, this is one array, and this is the I guess this is X test data. Yes, it has only taken some 2 rows as I see from yes, X train and X test. This is like this. Regressor, okay, actually linear regression won't work on it because it is a multi regression problem. So and it would give us an error. I was checking on it. I will see it later how we would be solving this problem. So this is on, this was only, this is how the error gets, we can see the errors if there is any. I won't probe into this error actually at this moment, and we will do it later. Now we can shift on to our GitHub problem. Actually, this was it. Okay. Now to install GitHub, who has the repository? Who has the profiles on GitHub? Does anyone know of GitHub here? GitHub.com. Let's see. We can all make logins here on GitHub. This is my login. See this. Here I will go on my profile. If you can see, this is my profile, and these are some popular repositories and I have some repositories here as well for myself. For example, these here, right? Let's see how we can create our own repository through GitHub. I have my GitHub installed. If you see here, this is here. I have installed my GitHub, and I would be working with Git Bash. Okay, are you all with me? Our participants have, I guess, we only have 5 participants now. Shall we move on or close here?
Yeah. Yeah, we can continue it from tomorrow onwards because it's been
Yes.
2 hours now.
Ji, Dr. Hafiz.
Yes, I'm saying that we can continue it from tomorrow onwards.
Okay. So we will discuss GitHub in the next session, as I think, right?
Yes, ma'am. Yes, ma'am.
Okay. So I can we can conclude here. I think. How did it go,
Yes,
Bill?
ma'am.
Let me know your feedback. Has anyone else?
I feel you did. You explained things, I thought, very well. In fact, I sent you a request, a copy of your slides, and I would suggest, since the recording started a little late, I would
Yes,
suggest here
exactly. Yes.
you can go in on Zoom, just on your own local Zoom, and record yourself presenting this again. And that way we would have a recording, because I think this could be of value to a lot of people.
Okay. Would do you suggest that I record it on my behalf in isolation and share it with you all? Yes.
Exactly. If you
Okay.
record it, and that way there's a number of other
I will make a
places that I
YouTube
would like to share
on
that
it
with.
from start. All right.
Mhm.
And share in group. Yes, I will do that.
Okay, great. Okay, I've got to run to another meeting as myself now.
Thank you so much for being there for so much time. Thank you, Bill, Dr. Hafiz, and there is another one guy. Thank you so much for attending.
Okay.
Thank you so much, ma'am. Thank you so much for all the lecture.
Bye, everyone.
All right. Allah Hafiz.
Goodbye, Bill. Thank
Bye.
you, ma'am. Allah Hafiz.
Allah Hafiz. Allah.